Okay, so let's come back here and take a look at 3.2. Thank you very much. Okay, so we started off, and actually the starter question was verifying an identity. It was a pretty simple identity. And basically the idea is they're asking, when they say verify an identity, show that this actually is a true equation. Show that this side would equal this side. So we went through on this one, we wrote everything in terms of sines and cosines, using those basic identities that we've already learned, okay, the stuff from chapter 1, and then kept simplifying. Notice we've got this Pythagorean identity here. We showed some work on how we'd rearrange the Pythagorean identity, and showed that, yes, indeed, this side, if we do this algebra and trig work, does look exactly like that side there. So the answer there is yes, we can verify that that is a true equation that makes it an identity. We went through and did a couple algebra things, like we multiplied these binomial expressions together, squared that binomial expression. We worked on factoring, okay, so reminded ourselves of some different techniques of factoring. And then we went through and kind of listed a couple different techniques or rules that you can keep in mind as you're trying to verify identities. The first one was work on the complicated side. The second one is you're going to be using a lot of algebra skills, especially things with factoring, complex fractions, different skills like that. A lot of times it's useful to write things in terms of sines and cosines because those are the most familiar ones. They're used in the definitions of the other ones, using those reciprocal identities and stuff like that. Okay, so that can be helpful. And above all, you've got to keep in mind that this sometimes is going to be frustrating. You're going to try something, it's not going to work. You're going to try something else, it's not going to work. It might take you half a page to do a problem. And I mentioned last time, if you're the type of person who likes to number your paper before you even look at the problems, that's an issue here, because some problems are going to be very short, and other problems that look like they're going to, look like they're going to take a long time are really short, and problems that look, oh, that's going to be pretty easy, might take you a long time and several tries to do. Okay? So if you need scratch paper, come and see me. But you do have some problems on your assignment that just say things like simplify or factor, and then we start doing things where we actually verify that that equation is true, in other words, that it's an identity. So we did a simple one right here where we just rewrote this as sine squared over cosine squared, canceled those off. I mean, some of the problems are literally that easy. Okay? We went through, used Pythagorean identity a lot, used odd and even identities. That is the more complicated side, okay? Just for the fact that the top uses an angle of negative x and the bottom uses an angle of x. I also said it would be a good idea as you're going through and doing these problems, make a little note off to the side as kind of a rationale why you did what you did or what identity you used to change it. Because going back and looking at your work for review, even if it's your own work, sometimes it can be hard to figure out what you did, okay? So if you write down that, hey, I used a not even identity here, I used a Pythagorean identity here, or a reciprocal identity or something like that, you're going to be in pretty good shape. You might remember this one right here, barked up the wrong tree for a while. We kind of rationalized, or we multiplied by the wrong conjugate. We multiplied by the conjugate of the bottom rather than the top. But we got to a point where we could see we almost had the right answer. It was just upside down. So we flipped this over, okay? Or in other words, we multiplied by the conjugate of the top rather than the conjugate of the bottom. Did some simplification with some Pythagorean identities that we have right here, and turned out that it wasn't that bad to verify. I did mention you could do this side here, but it's tough to go that direction, okay? All right, any questions so far? Okay, you started working on 3.2, didn't you? Yeah. Hopefully you did, very good. Okay, said verify that's an identity. Again, there's not really a side that's easier than another, but I said generally speaking, we're better at simplifying things. We're better at combining things together than we are at breaking them apart. Okay? So we got a common denominator, got this. Used a Pythagorean identity to put a 1 on the top. And then again, this is generally kind of an unnatural thing for us to do. We broke this fraction into two pieces. They were multiplied on the bottom. I did 1 over sine and 1 over cosine, which I then have a cosecant here, and there I have a secant. Okay? So we verified it that way. Okay, all right, let's take a look at these last couple. Again, just a quick reminder, we did some Let's see. Just a reciprocal identity here and here. Did some canceling, and then a quick Pythagorean identity. Okay, not a very difficult one. That's a pretty good candidate for a test. You'll probably have 5 or 6 identities to verify on the test that you take in a couple weeks. You're going to have some easy ones, and then some that are going to challenge pretty much everybody in here. Okay, some easy, some medium, maybe one difficult one on there. Okay, all right. This one right here is an interesting one. There are more than one way to approach that. Okay, so if you checked with your neighbor, they may have tried this problem a different way. And let's see. We got done with this one. Let's just double check our work here. We worked on this side over here, factored it, canceled off that common factor, just had 1 plus sine of x. And then we worked on this side over here. We broke that into 2 pieces. That was somebody's suggestion. Okay, cosecant over cosecant is 1, and 1 over cosecant is sine. And then we said, well, gosh, I've worked on this side and made it look like 1 plus sine. I've worked on this side and made it look like 1 plus sine. So I can just draw arrows between the two and say, hey, the 2 sides are equal to each other. But I mentioned at the end, is this the best way to do the problem? Usually it's best to keep your work on one side. Okay, but I did warn you, there's one thing you cannot do when you're solving these and doing some algebra. Does anybody remember what it was? Okay, you can't move stuff from one side to the other side, because if you move stuff from one side of the equation to the other side, you're already assuming that it's true. Okay, and that doesn't work. Okay, any questions? Okay, then let's do the last 2. Let's take a good look at this one. And we said it's good to work on the complicated side. That's pretty easy to spot here, isn't it? Does this one look bad? Okay, at first glance it might look pretty ugly. Okay, but we can clean this up really quickly, again using those odd-even identities. Is sine an odd function or an even function? It's odd. So what's the net effect with an odd function? Yeah, you kind of pull the negative out front. Okay, that's not technically what you do, but that is the net effect. So I can take this one and this one, and I can change both of them. Now watch, please. Everybody watching? Okay, this is going to be 1 minus a minus is a plus. Good there? If I pull the negative out front, this is going to be 1 plus sine squared x. Now, I want you to take a good look at that. Okay, raise your hand if you think that's correct. Raise your hand if you know it's not correct. Raise your hand if you don't want to raise your hand. Okay, there we go. Okay, I think we got everybody now. Is this right or wrong? I hear mumbling. You're right, it is wrong. Yvonne, for the simple fact I wouldn't be asking if it wasn't wrong. Okay, but I heard a couple people say this is wrong. Can somebody tell me why this is wrong? Kahala.
Well, because when you square the negative, then it turns to positive, but you still have the negative in front.
Very good. Okay, let me here's the idea. When I plug this identity in, okay, remember this really means sine of negative x quantity squared. We put the square right there. That's just notation. It literally means the sine of negative x. Get that answer, then square it. So let me write down what we should do, okay, or what we should at least think about. This is negative sine of x. So if I square this, I have 2 negatives here. I have another one outside. Altogether, I've got 3 negatives. 3 negatives make a negative. And that's a good thing because I couldn't do anything if that weren't negative. Once I get to here, what do I do? I heard it. What's the correct thing to do here? Factor this. This has a name. It's not a perfect square. Difference of squares. It's a difference of squares. Okay? In fact, okay, I kind of blew this up for a reason. Didn't we use that right here? Difference of squares. Okay? So this factors to 1, whoops, I'll do it down here, keep it on the same side. This factors to 1 minus sine of x, 1 plus sine of x, and the denominator is 1 plus sine of x. Yeah?
So can you not use cosine for x because 1 minus sine?
Okay, so the question there is, would we want to change that? Because 1 minus sine squared is cosine squared, right?
Yeah.
Okay, I want to keep in mind what I want to make this look like.
Okay.
I want to make it look like a 1 and a sine. So if I throw a cosine in there, I'm changing it into a trig function that's not in the other side. Now that's not always wrong, but in this case it would kind of be going down the wrong path. Okay, it would get us further from where we want to go. Good question though. Anything else? Cancel off the common factors. So this is 1 minus the sine of x. I can circle that and say, hey, look, I made this side look like the other side. This is a true identity. Let's run back through here and at least keep in mind what we did. What substitution was this? Or what identity? Okay, so I'd do maybe an odd even right here, just to remind us what we did. How did we go from here to here? Okay, factor, we could even write difference of squares. I'm not so interested in you saying, you know, canceled factors, okay? But we could keep that in mind. Okay, are there any questions on that one? Sure? Okay, everybody got that copied down? Okay, take a look at the last one then. Would you try and verify this last one? How bad does it look? Looks pretty ugly to me. Okay, go ahead and try it. And when you're done, check with your neighbors, see if you got the same thing. I'm going to flip the light on. My gosh, look at all those functions floating around there. Trig functions squared. Maybe we'd have to use a Pythagorean identity to figure this out. So you done? Did you check with your neighbors? Is your neighbor done and you're still barking up the wrong tree? Because is this a difficult one? This should be an absolute breeze, shouldn't it? Because this would be 1 minus, what's the general technique here? Right, in terms of sines and cosines. So this is going to be sine squared x. This is going to be 1 over sine squared x plus sine squared x over cosine squared x.
Would it be 1 over cosine squared x?
What's that?
Would it be 1 over cosine squared x?
Where? Here?
Yeah.
This is cosecant. Cosecant is the reciprocal of sine. Secant is the reciprocal of cosine. Okay? This is right, isn't it? B. Woods, you confirm that? Thank you very much. Okay? What do I do here? Okay, cancel those babies off to be a 1, right? So here's really what I've got. 1 minus 1 plus sine squared x over cosine squared x. Those cancel to be 0. Now, when you say cancel, if you would, please be careful about the way you say that. These cancel to be 1. These cancel to be 0. Okay? You don't just throw around the word cancel without knowing what it means. This is sine squared x over cosine squared x, which is tangent squared x. Piece of cake, right? Great type of test problem. Okay? It looks awful. It's easy. Any questions? Reciprocal identity here. Just some algebra and arithmetic here. Sine and cosine in terms of tangent in terms of sine and cosine. Okay, so the tangent identity there. Okay. Nothing else? Okay. All right, so here's what I want to do.